So picking back up in this problem, hopefully you remember that I is the square root of -1. So I could rewrite that as plus or minus 3 times the square root of -1. And if you're asking, well, how did they get 3? Well, 3 squared is 9. So really they said you had plus or minus the square root of a -9. So if you ask yourself, well, what's the square root of -9? 3, but it's negative, so 3i. So just kind of going backwards, remember they gave us the zeros, we have to go backwards. So you need an equation where you're going to get that as your answer, where x is going to equal that, the square root of -9. So if I go backwards, I'm going to square it, because remember if x equals 1, subtract 1, x minus 1 equals 0, so that's where I'm getting that factor from. But on this, square both sides, so I get x squared equals -9, add the 9, so you get x squared plus 9, and that's your other factor. So for my first factor, I get x minus 1. For my other factor, I get x squared plus 9. That's where those are coming from. And remember, you could rewind and pause if you want to see that process again. So it wants it in standard form though. So like the last one where it was intercept form and you can just stop, this one wants standard form, which means I have to multiply x squared plus 9 times x minus 1. And remember, it doesn't matter what order you do it in. So x squared times x is x cubed. X squared times -1 is -x squared. 9 times x is 9x. And 9 times -1 is -9. So there's your polynomial function in standard form. That's it. So it seemed really complicated, but if you know that x equals, let's do another one, plus or minus 2i, that would be plus or minus 2 times the square root of -1 to go back under the radical, square it. So I get 2 squared is 4, so plus or minus the square root of -4. Remember, square root, I put that plus or minus, so just get rid of it. X equals that, square it. So x squared equals -4. Add the 4. Basically, it's the opposite of a difference of squares. So that's what we're working with. Okay, now down here on these ones, some are factored, some aren't. All it says is solve. So you have to find out the roots, in other words, x-intercepts, zeros, whatever you want to call it. But taking a look at this first one, this piece could equal 0. Remember, that's called zero product property. So x squared minus 1 could equal 0. Or the second piece could equal 0. X squared plus 4 could equal 0. And now I'm going to solve. So add 1, x squared equals 1, square root, and I get plus or minus 1, square root. Over here, subtract 4, so I get x squared equals -4, square root. We just did that a second ago. Plus or minus 2, but I, because it's negative. So for solutions, x could be plus or minus 1 or plus or minus 2i. For solutions, because notice, x squared, 2 plus 2 is 4. You should have 4 solutions or 4 answers. Okay, if I asked you, what's the multiplicity of each one? Well, the multiplicity of each one is 1. Okay, over here, x to the 4th equals 16. Well, if I set it equal to 0, I get x to the 4th minus 16 equals 0. Hopefully you're recognizing this as something. I can't set up my x. I mean, I could try to factor by grouping. Those are both perfect squares. What's the square root of x to the 4th? X squared. What's the square root of 16? 4. Remember ds, difference of squares. So x squared plus 4 times x squared minus 4. And if I do this correctly, I should get 4 answers. So x squared plus 4 could equal 0. Subtract 4, we just did this on the last one. If x squared equals -4, then x could be plus or minus 2i after square rooting it. Over here, I have x squared minus 4 equals 0, so I get a positive 4, which you're allowed to square root without an I, and so it could have plus or minus 2i or just plus or minus 2. So that's 4 answers. That's 2i, that's -2i, that's positive 2 and -2. 4 answers, x to the power of 4, which means the multiplicity of each one has to be 1. If you add up your multiplicities, they have to add up to whatever your highest exponent was. Taking a look at another one. Remember, when factoring, it has to be equal to 0. So if I'm going to solve this by factoring, which you don't really have a choice, it has to equal 0. So subtract that over. Now it equals 0. Ask yourself, is there anything that all three terms have in common? And that's yes, they all have an x. So I'm going to take out x. I'm left with 2x squared minus 5x minus 3. Set up your x to solve it. So it's a trinomial. I don't have to factor by, I can't just split it in half. There's nothing special about it. So sum to -5. Product is -6. I'm going to give you a minute to think about it. At -6 and +1. If you did 2 and 3, -2 times -3 would give you a +6. There's no way you could get a product of -6 with the 2 and the 3 because one would have to be negative, one would have to be positive. So now I'm going to break up that middle term. And then I'm going to group it. So taking a look at the first half, I can take out a 2x, and I'm left with x minus 3. Out of the second half, I have to take something out. I'm going to take out a 1, and I'm left with x minus 3. So in factored form or intercept form, I get x times 2x plus 1 times x minus 3 equals 0, which means that piece x could equal 0. If 2x plus 1 equals 0, I'm going to subtract 1. So I get 2x equals -1, and then divide by 2. So I'm actually going to get a fraction answer. And then for the last part, x minus 3 equals 0, add 3, and I get x equals 3. So I have three solutions. X could equal 0, -1/2, or 3. Well, three solutions to the power of 3, I did it right. Each one would have a multiplicity of 1. That's it. Taking a look at the next one. Once again, doesn't equal 0, has to equal 0. So I'm going to subtract 6x cubed, so I get 3x to the 4th in order minus 6x cubed plus 12x squared equals 0. They have an x squared, but it's not just an x squared, it's actually a 3x squared that I'm going to take out. And that will leave me with x squared minus 2x plus 4. So set up my x, sum to -2, product to 4. And the issue is that they don't exist. So that should be a squared right there. So the issue is there's no numbers that go right here, which means if you have to solve this and factoring is not an option, factoring's out. Question is, do you want to graph it? No, probably not. Do you want to complete the square? Maybe you do, I don't. So ask yourself, what's the one option that works when all else fails? Hopefully you're singing the song, Quadratic Formula. So I have 3x squared. I know that could equal 0, like that. Divide both sides by 3x squared could equal 0. Square root at x equals 0. With a multiplicity of 2 now, because it was an x squared. But how are you going to solve this? Well, I got no choice but the song. It doesn't factor. I don't really want to graph it. Completing the square is probably out. So x equals -b would be 2 plus or minus the square root of -2 squared minus 4a times c is 1 times 4 all over 2a. 2 times a is 1. So -2 squared becomes +4 minus 4 times 1 times 4 is 16. So that becomes 2 plus or minus the square root. 4 minus 16 is -12 all over 2. And now you have to clean that up. So remember the square root of -12. Well, I'm going to take out an I, but I have 4 times 3. 4 is 2 times 2. So I'm going to take out a 2. So I get 2 plus or minus 2i, because it was negative 12, square root of 3 all over 2. And then notice all those 2's, those can all reduce to 1's. So one of my answers was 0. My other answer is going to be 1 plus or minus 1i root 3. And remember, that's two different answers. That's 1 plus I root 3, and that's 1 minus I root 3. So that each one has a multiplicity of 1. Well, 1 and 1, that had a multiplicity of 2 because it was x squared. Although this was x squared, you get plus or minus, which kind of breaks down the multiplicity. So 2 and 1 makes 4. You know you did it correctly. So sometimes they work out really nice and neat when factoring. Sometimes not so much. Sometimes you have messier solutions. So if you feel really good with factoring, you can skip over, video part 3 and just jump into video part 4 with this. But if you need some extra practice with factoring, we're going to really dig into some more complicated ones here in just a little bit.